Hello, this is Dr. Ayashola Ogunele, Astronautics for Exploit. Lunar Resources, indisputable catalyst for lunar economy. The overview is as follows. Lunar Resources, uses of lunar resources, types of lunar resources, and long-term crewed missions to the moon. Lunar resources, which are tremendously valuable to the human on Earth and have various future applications, are vast and abundant on the moon. In future, the lunar resources will help in facilitating human activities on the Cis-lunar system and also underpin industrial capabilities. Cis-lunar space, the volume of space influenced by the Earth and Moon, will enable easy routine access to and from the surface of the Moon, serve as depot for the mined lunar resources, helping safeguarding expensive space assets, assessing all other regions within the lunar space, for example, low Earth orbit, medium Earth orbit, geostationary Earth orbit, and low lunar orbit, and actualization of interplanetary flights to the Mars and beyond. Lunar Gateway, a planned space station in lunar orbit for the purpose of serving as a science laboratory facility, area where rovers and robots could be kept, solar-powered communication hub, and short-term habitation model, is intended to be positioned in cislunar space. The presence of Lunar Gateway in cislunar space will help in expanding human reach beyond the LEO and establishment of this space transportation system. The vast natural resources available on the moon are solar power, oxygen, water, hydrogen, silicon, iron, magnesium, calcium, aluminum, manganese, titanium, and rare earth elements. Based on the abundant solar power, solar cells could be manufactured directly on the lunar soil. Rare earth elements can be used for manufacturing electric and hybrid vehicles, wind turbines, electronic devices, and clean energy technologies. Unprocessed lunar soil, also called regolith, may be turned into usable structural components through techniques such as sintering, hot pressing, liquefaction, the cast basalt method, and 3D printing. The lunar soil can also be mixed with carbon nanotubes and epoxies in the construction of telescope mirrors. Water molecules can be decomposed to its elements, hydrogen and oxygen, and form molecular hydrogen and molecular oxygen, which can be used as rocket biopropellant. Hydrogen will be needed for propellant production, and it has a multitude of industrial uses. Magnesium has multiple uses as alloys for aerospace, automotive, and electronics. Titanium can be alloyed with iron, aluminum, vanadium, and molybdenum, among other elements, to produce strong, lightweight alloys for aerospace. Lunar resources. A lot of resources are bound on the lunar surface and underground the moon. Moon natural resources. The moon bears vast amount of useful natural resources, and efforts are being directed by the government space agencies and private space companies to tap and exploit the resources for the benefit of humankind. A rendering of a possible lunar habitat is shown here. Lunar Resources is facilitating continuous exploration of the moon itself, scientific and economic activities in the vicinity of both the Earth and the moon, called Cis-lunar space, and could also be imported to the Earth surface, where they will contribute directly to the global economy. Artist's impression of lunar in situ resource utilization concept is shown in this picture. There are different types of lunar resources, and some of them are highlighted as follows: solar power, rare earth elements, lunar regolith, oxygen, nuclear power, helium-3, carbon and nitrogen, water, hydrogen, and metals. Rare earth elements is one of the lunar resources. Except of promethium, the Earth's crust contains large amount of rare earth elements. Due to their geochemical properties, rare earth elements are typically dispersed and not often found concentrated in rare earth minerals. As a result, economically exploitable ore deposits are less common. In spots rich in potassium and phosphorus, the moon could host real mines on par with the best ones that we have at the Earth. Concept of lunar flashlight in a position over the south pole of the moon is shown here. Based on research findings, rare earth elements are less abundant on the moon than on Earth. The view on the mining of rare earth minerals as a viable lunar resource because they exhibit a wide range of industrially important optical, electrical, magnetic, and catalytic properties. Artist's concepts of a moon village on the lunar surface is shown in this picture. Solar power. Solar power is one of the lunar resources. Daylight on the moon lasts approximately 2 weeks, followed by approximately 2 weeks of night, while both lunar poles are illuminated almost constantly. Lunar South Pole. The lunar South Pole features a region with crater rims exposed to near constant solar illumination, but the interior of the craters are permanently shaded from sunlight and retain significant amounts of water ice in their interior. In this video, we have a complete lunar day. Lunar regolith is another lunar resource. The lunar surface is covered by a layer of unconsolidated debris called the lunar regolith. On the moon, regolith occurs as a mixture of powdered dust and broken rock. Lunar regolith is formed by the impact of meteorites on the body's surface. The force of the collision melts some of the impacted regolith to form objects known as agglutinates and EIFS debris outward from the point of impact. An early lunar outpost design is shown in this picture. Since the moon lacks any sort of an atmosphere, the upper few millimeters of the regolith is exposed to the bombardment of micrometeorites and to solar wind irradiation. The extensive bombardment by micrometeorites, which continues till today, breaks up soil particles and melts portions of the soil. This picture shows moon rocks from the Apollo 11 missions. Oxygen is another resource that can be found on the moon. The elemental oxygen content in the regolith is estimated at 45% by weight. Oxygen is found in iron-rich lunar minerals and glasses as iron oxide. Different proposals have been put forward for the extraction of oxygen from lunar regolith. Artist's concept of a spacesuit-clad astronaut outside the habitat on the surface of the moon is shown in this picture. Another resource that can be found on the moon is nuclear power. Uranium and thorium are both present on the moon, but due to the high energy density of nuclear fuels, it could be more economical to import suitable fuels from Earth rather than producing them in situ. Concept of a lunar base is shown here. Water is another resource that can be found on the moon's surface. Evidence from several lunar orbital missions show that water ice is present on the lunar surface at the moon poles, but mostly on the South Pole region. Water may have been delivered to the moon over geological timescales by the regular bombardment of water-bearing comets, asteroids, and meteoroids, or continuously produced in situ by the hydrogen ions of the solar wind, impacting oxygen-bearing minerals. The future of mining on the moon is shown in this picture. Carbon and nitrogen. Carbon is useful for the production of lunar steel, but it is present in lunar regolith in trace amount, contributed by the solar wind and micrometeorite impacts. Carbon and fixed nitrogen will be required for farming activities within a sealed biosphere. The moon, as seen along planet Mars, is shown in this picture. Helium-3. The solar wind deposited more than 1 million tons of helium-3 to the moon's surface. Materials on the moon's surface contain helium-3 at concentrations estimated between 1.4 and 15 parts per billion in sunlit areas and may contain concentration as much as 50 parts per billion in permanently shadowed regions. For comparison, helium-3 in the Earth's atmosphere occurs at 7.2 parts per trillion. Proposed lunar outpost is shown in this picture. Methods. Some methods are also seen to be found on the lunar surface. Some of them are as follows. Iron. Iron is abundant in null-mere basalts, but is mostly locked into silicate minerals and into the oxide mineral ilmenite in the lowlands. Titanium exists almost entirely in the mineral ilmenite. Calcium is the fourth most abundant element in the lunar islands, present in anorthite minerals. Interior of a 3D printed section of planned moon village is shown in this picture. Aluminum is found with a concentration in the range of 10 to 18% by weight, present in a mineral called anorthite. Silicon is an abundant metalloid in all lunar material with a concentration of about 20% by weight. Magnesium is present in magmas and the lunar minerals. This picture shows distribution of surface ice at the moon's south pole and north pole. Hydrogen. The solar wind implants protons on the regolith, forming a protonated atom, which is a chemical compound of hydrogen. Robotic construction of lunar and material infrastructure is shown in this picture. Uses of lunar resources. Lunar resources are very useful for various purposes, and some of them are highlighted as follows. Rare earth elements. Rare earth elements are used for the manufacturing of electric and hybrid vehicles, wind turbines, electronic devices, and clean energy technologies. The elements are also useful in cell phones, batteries for electric cars, military equipment, fluorescent lights, and a host of others. This picture shows Apollo 17 astronaut Smith standing beside a boulder on the lunar surface. Solar power. By locating a lunar resource processing facility near the lunar South Pole, solar-generated electrical power will allow for nearly constant operation close to water ice sources. Solar cells could be fabricated directly on the lunar soil by a rover with the capabilities for hitting the regolith. Illustration of Artemis astronauts on the moon is shown here. Lunar regolith is another type of lunar resources. Unprocessed lunar soil, also called regolith, may be turned into usable structural components through techniques such as sintering, hot pressing, ligation, the cast basalt method, and 3D printing. Meteorites. The lunar soil can be mixed with carbon nanotubes and air pulses in the construction of telescope mirrors up to 50 meters in diameter. This picture shows an imagined future moon base. Nuclear fission system. Nuclear power is another lunar resource. The kilopower nuclear fission system is being developed for reliable electric power generation that could enable long-duration crewed bases on the moon, Mars, and destinations beyond. This system is ideal for locations on the moon and Mars where power generation from sunlight is intermittent. Illustration of a proposed industrial base for mining water and producing propellant at the lunar pole, featuring crew habitats, robotics, and industrial equipment is shown in this picture. Water. Water molecules can be broken down to its elements hydrogen and oxygen and form molecular hydrogen and molecular oxygen to be used as rocket biopropellant and produce compounds for metallurgic and chemical production processes. This picture shows Apollo 12 lunar model. Hydrogen. Hydrogen will be needed for propellant production, and it has a multitude of industrial uses. For example, hydrogen can be used for the production of oxygen by hydrogen reduction of ilmenite. Illustration of moon surface containing resources is shown here. Magnesium has multiple uses as alloys for aerospace, automotive, and electronics. Titanium can be alloyed with iron, aluminum, vanadium, and molybdenum, among other elements, to produce strong lightweight alloys for aerospace. An Energia-launched automated lander descends toward the target lunar landing site, bearing a cargo of automated lunar oxygen mining and processing equipment is shown in this picture. Long-term crewed missions to the moon. In situ resource utilization. When astronauts live and work on the moon, they will need access to life-sustaining oxygen, water, and other resources. On the moon, and eventually Mars, they could collect local resources on the surface and transform them into breathable air, water for drinking, hygiene, and farming, rocket propellants, and more. It's a practice called in situ resource utilization. Concept of rocket mining system is shown in this picture. For long-term crewed missions, astronauts will be living in space for longer and longer periods of time and carrying all the water, oxygen, and rocket propellants which are needed to sustain life. This picture shows illustration of a lunar polar mining base. ISRU could reduce the mass and cost of launching products that are needed to sustain the crew. It could also help power outposts or refuel space vehicles. These critical supplies will be derived from space resources such as the carbon dioxide-rich Martian atmosphere and water on the Moon, Mars, and asteroids. Illustration of the Skyline mission lunar mining concept is shown in this picture. For more information, contact Astronautics for Exploit. You've been watching and listening to Lunar Resources, Indisputable Catalyst for Lunar Economy, presented by Dr. Anyashola Ogundele, Astronautics for Exploit. Thank you.